So, very good evening, one and all. Again, we'll meet with a new talk or title Application of Artificial Neural Network in Talent Management. Right? Seeing lot of uncomfortable this class today because I'll tell more about some mathematic work and end of the today you will be enjoy. I mean, you will know how the NN will give the solution. So, artificial neural network, I'll tell you briefly. But if you know artificial network is 100%, so you will get 10% of that today. Okay, it is a very vast area. But I'll tell the very fundamental things and so that you will learn and you try to love the subject, the class today. So definitely you will get, definitely you will be gaining. Somehow you will get it. Okay. So my voice audible to all of you?
Yes.
Yeah.
Yeah,
Now,
for me.
Yeah. Now I'm asking question. What is this? I'm asking to you.
The map of India.
Map of India. Everybody agree map of India, right?
Yep.
Okay. How do you know it is the map of India?
By the boundaries.
School days, yeah.
Well, can you tell one by one? How do you know it is a map of India?
By the boundaries.
Sorry, go ahead.
By the boundary?
By the boundaries, outlining boundaries.
Okay. Anyone response?
Sir, I have seen it over years.
Okay.
This has
Okay.
been taught to us.
Yeah, in school
Okay.
days.
We have been taught the same from childhood.
Okay. Very good. Next. Any query? Any response?
So what is the question? So, just joined.
Question. What the last person asking?
So
what is
what
my
is the-
question?
Yes, sir. I just joined, sir. Sorry. Just wanted to check.
Okay. You are looking the figure, right?
Yes, sir.
What is the figure?
It's a map
Map of whom?
of a country, sir.
Which country?
Hindustan.
India, right?
Yes, sir. Bharat. Yeah.
Okay. How do you know it is the map of India? This is my question.
Okay.
Tell me.
As per our memory and the information set up to us.
Okay. So many responded I received.
As per geography books, sir. So,
As
Oh.
per the figure,
And-
as
and
per
the-
the shape.
All are correct. What I'm saying, everybody know this type of image is nothing but outline of map of India, right? Am I correct? Because in childhood, one participant in childhood, you learn this is called the map of India, right? That means this is present in your memory. Am I correct?
Yes,
sir.
Now, the moment look at the picture, your eyes receive the input, pass the information to your brain. A brain having some processing is going on, and brain give the signal to your mouth. Tell this is the outline picture of map of India. Correct? Now, receiving the input, something process is going on and giving the output. This is the role of not artificial intelligence. It's called the human intelligence, right? And this is called the neural network. That means your brain gives the signal to your mouth or memory, they retrieve and give the signal. This is called the map of the India, right? How it is happening? There is a fourth step. Receiving the input, pass the message to the brain retrieve the memory, then this image will be pass the matching with memory, and memory will identify, then pass the information to the brain, and brain will be processing and brain will give the signal. And what is the signal? Yes, this is the map of India, right? Now, this is called the cognitive capability, right? Now, what the first map belongs to which country? The first signal represent what? The first picture. Anybody can tell me the first picture.
South Africa.
South Africa. This is South Africa, right? Is it South Africa?
No,
sir.
I don't know about the one. The second one is Australia and the third one is Sri Lanka. First one, I'm not sure.
Okay. So this is you don't know because you don't have a scope in your past experience. This type of country or you can outline. This is called the Zimbabwe, right? And absolutely this is Australia and this is nothing but Sri Lanka. You are correct, right? So what I want to say, why these two you speak or respond quickly, why not this one? Because this image you don't have in your memory. This image you don't know anything about as of now, right? But similarly, these two images you prominently know, that means you're too much acquainted with these two images. So that's why the moment you pass the information to the brain unable to tell because the memory is not found. That memory is not found. That means it's not a role of artificial neural network. It's a natural human being knowledge are unable to represent this type of picture, the first picture, right? The first picture, this is second picture, this third picture, right? So the first picture are unable to tell. None of them do. I also don't know, right? So if today onwards I remember this type of image somebody asks tomorrow, then I can tell, right? So coming to same thing, the first animal, anybody can tell? The first animal?
Monkey.
Monkey. The monkey belongs to Indian monkey, right? Second one?
Koala.
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 Yes, koala. And third one?
Fox.
Fox.
Fox. Wolf,
Hi.
right?
Wolf, yeah.
Okay. So here what we'll do, what I'm saying, this prominent picture or these figures, right? Maybe any animal, okay? So this is present in your memory picture, right? The moment you ask this image by receiving input, by looking the picture, you receive the input from eyes, passes the information to your brain, and brain having some analysis, and brain give the result, this type of figure is called the monkey, and this is the koala, animal frequently available in Africa region, and this is the wolf, right? So this is nothing but your natural neural network. Neural network means your brain functioning perfectly, right? Now, suppose I will ask 24 plus 18, how much? Suppose I will ask 2 plus 4, how much?
6,
6. 12 plus 14, how much?
26.
1, 2, 4 plus 3, 8, 6, how much?
I don't
You
know.
take time. You take
610.
time. So you take some time, right? The moment I'm saying 2 plus 4, immediately you tell 6. The moment I'm saying 12 plus 14, immediately saying 26. The moment I 3 digit, you take some time. The moment I 4 digit, you take more time. The moment I 5 digit, you are unable to tell. That means human brain having limited cognitive capability. Human brain having calculation or storing the information, having some limited memory. Suppose 1 plus 4, immediately no need to addition, you immediately tell because you did addition then and there with a very fraction of time because you know this addition very well. So when you get 3 digits, you need some time and store the memory, then calculate, then you tell. So this is happening in human brain, right? And this brain is nothing but we cannot call it the artificial neural network. It's called the natural neural processing unit, right? Now, how this happening? Today I'm going to in depth. The artificial neural network first start in 1943 by two persons. This is called the McCluskey and this is called the Walter Pitt. The Pitts and McCluskey, right hand side is called the Pitt and the left hand side called the McCluskey. Both are the professor, University of Illinois at Chicago. They introduced first concept in 1943 that is called the how human brain works, why not system will be understand that system. So they developed a article, a logical calculus of the ideas imminent in nervous activity. How human brain works. As you know, adult human brain having each number of neurons are there. So number of neurons is equal to 48 millions of neurons are there. 48 millions of neurons. Now imagine. Each neuron activity, I'll tell you how they will work. Similarly, 48 million of neurons working simultaneously and passing the information to each other. So these two scientists are Nobel laureate are starting the concept called the artificial neural network. People are using the artificial neural network become popular in 1965. Though they introduced 1943, but after around 20 years time, so it take time to become popular. People are using artificial neural network. Nowadays, machine learning is based on artificial neural network. As of now, what you discussed, like KNN, K-mean, these are the basic things. The recent, the AI tools, no one use K-mean, no one use KNN, people are using the artificial neural network. So I'm going to discuss more about the biological neural network and the artificial neural network, how they correlate. Coming to biological neural networks, as I already told you, 86 billion number of neurons are connected, and each neuron are called the perceptor, Perceptor means the perceive. Human having 5 indriya, they having perceive. And each perceive are nothing but the input signal receive. Input signal, suppose you touch ice, you feel cold. Suppose you touch hot water, you feel hot. So this is nothing but your perception through your screen. Something you observe your eyes. So that is called the eye perception. Something you smell. Okay, so these are the different things. Now, the human brain having all type of 86 billion of neurons, and basically they work is nothing but the movement called the sensation, thought, movements, and each neurons are connected with the help of chemical substances like sodium, potassium, calcium, all the chemical symbols, all chemical substances, sodium, potassium, K plus, sodium, Na, and calcium, all these chemical substances are connected through each neurons. Now, I'm explaining each neuron, how it looks. This is called the biological neuron. So biological neuron, what happened? This is called the nucleus. In nucleus, what happened? All processing happen. And nucleus present in the body of the cell. And this is nothing but the structure of one neuron. Remember, structure. So similarly, billions of neurons are there. So how many neurons are there? 86 billions of neurons. Adult brain. I'm not taking child brain or new baby brain. No. Adult brain, 86 neurons are there. 86 million of neurons. So each neuron having nucleus, axon, dendrite, synaptic terminals, telodrines, these are all the different types of that. And very interesting things you see, the nucleus will process the element, right? Let me different color. Nucleus will be processing the element after receiving the input signal by dendrites. And after that, what happens? They pass the information to axons. So this is called the axon, right? So there are connection junction, okay, connection to another neuron, right? So out of all bunch of neurons, they're connecting through human brain. Here, this is suppose human brain. So this is the body of the brain. So these are called the bunch of spinal cord. This is the spinal cord. And all the information passes to spinal cord. That means all the brain signal, suppose the link to head, link to mouth, link to eyes, link to leg, link to finger, everything, right? So these spinal cords are passing the information or from the different body organs to your brain. Right. So this is nothing but a cable-like structure, like a bunch of cable. You open an electric cable, the way that finds lot of wires are there, fine-tuned wires are there. Similarly, here what happens, small-tuned the nerves are there. So these bunch of nerves are connecting to the brain. Now coming to how the multiple sides of brains, they passing the information and how the people are using the biological neural network to convert to artificial neural network. So these are the roles of the biological neural networks. So what is the role of the dendrite? Is nothing but inputs. Receiving the inputs by dendrites on the basis of signal. Suppose in a artificial neural network, we called here as a X1, X2, X3, right? So similarly, we can synapses weights are there, and this weight is nothing but in our biological neural network are nothing but the chemical substances like your sodium, potassium, calcium, like that. But in a artificial neural network, these are weight is nothing but 0 to 1 for the linear way, and minus 1 to 1 is nothing but the nonlinear way. Similarly, soma is nothing but the cells body, the processing unit, and the processing unit is nothing but all input having x1, x2, x3, they multiply by w1 and together by n, and the output what will get, that is the dependent by the processing unit in terms of artificial neural network. Then activation function will be fired. Some activation function is there. The role of activation function is to take the linear way or non-linear way. If it's linear way, then what happens? The threshold function will be 0.5. Those values greater than 0.5, it will be fire. And those values less than 0.5, it will be not fire. So in this way, the neuron will be work. And the axon is nothing but output. So output as it tells what should be the output of the one layer to another layer. So in this way, we can compute the artificial neural network. Now coming to the compare, this is called the biology neural network and the artificial neural network. In artificial neural network, what happened? So these x1, x2 are called the input. And this is not only one input, this is n number of inputs. So this n number of input, we make it a matrix way and n into n. So let me give one example here. For example, in this class, suppose 60 participants are there and 60 participants having own features. Own feature, right? Suppose participant number 1, suppose I call the height. Participant number 1, suppose weight, hemoglobin level, okay? Suppose the habit, fooding habit, veg or non-veg. So height is equal to 5.6, I can put 5.6. Weight suppose 60, hemoglobin suppose 12, and non-veg suppose 1. Veg is equal to 0, non-veg 1. So in this way, we call one row having 60 number of participants. So this is nothing but the 5 into 60 number of data. Are you clear or not clear? Tell me. Are you clear? Are you clear here?
Yes, sir.
So this matrix will passes to all this information to the neural network. The neural network, not single input they'll take. So taken the one matrix, right? So one phase by phase will take. So phase by means first suppose a participant number 1, participant number 2, participant number 3, like that participant number 60. So after that, what happens? Some activation function or processing unit will be find out. We have to take the processing unit F on the basis of W1 X1. What is W1 X1? So weight 1 is nothing but some random number, as I already told you, -1 to 1, random number is there. So this random number is multiplied by height, multiplied by weight, multiplied by hemoglobin level, multiplied by non-veg or veg. Then give some information, suppose x11. Similarly, input nothing but x12, nothing but s13, like that x160. Then take the summation of this total one, will get here xt1. In this way, the first phase, second phase, third phase, all the passes the information to the another signal or another neurons or another perceptron. On the basis of this output, we'll identify what will getting the output, whether male or female. Suppose my output is male and female. On the basis of this, I can identify the male and female, right? So when you compute a particular neuron, so neuron having different types. One is called the unipolar, one is called the multipolar, one is called the bipolar, exanorchic, and pediasonic polar, pseudosonic polar, like that. Okay. So what is the meaning this one? Unipolar means one neuron only passes the informations, only one category. Bipolar means two. So this cell body receiving the input signal from this end and receiving the input signal from that end. Similarly, the multipolar, more than information can receive. So in this way, different type of neurons or activations are there. Now coming to a biological neuron, dendrites is nothing but input signal. Synapse is nothing but the weight. Cell body is nothing but the processing unit or node or neuron or perceptron, both are same. Axon is nothing but the output signal. And neural firing means activation functions. So role of activation function will identify to getting the input, what you receive. By using some mathematical function, you can compute and give the results. So that is called the role of the activation function. And activation function is two types, either non-linear and the linear way. Now, what is the learning objective? The fundamentals of ANI, we can call ANN.
Mohanty.
Yes.
So what is weights mean there in science synapse? When you say
Okay.
weights, what is that?
Here in a biological neural network, weights means some signal passing through the chemical signal, that is of the sodium, potassium, calcium, like that. Okay. Something you might be heard during our grandfather, grandmother, they become memory loss, right? Why? Because the sodium, potassium level very, very
Came
less, right? So that's why what happened to memory loss means one brain part of the human being, that is the ambigula, right? The ambigula, what happened? The ambigula will be less receiving the input, the signal. So oxygen will not supply to the particular sufficient amount. That what happened? That will be not activated. Okay. So that's why some signal will go losing. So same thing in your artificial neural network, this weight is nothing but random weight from -1 to 1 or 0 to 1. If it is non-linear, from -1 to 1, for linear means 0 to 1. Hope it is clear, right?
Right.
Okay. Now, the comparison between biological neural network and artificial neural network, the basic model of ANN, what I discussed, then define different types of connection, artificial neural network or ANN, how they become learning and activation function, are they work, and the basic two fundamental I have to discuss is very, very important. That is called the McPickless, that is the two scientists, the father of the artificial neural network, and the student is a Hop neural network. So both are same. The McHop become the student of McCullough and Pitts, both are the same university, right? So these two different neural networks I have to going to explain. The fundamental concept is there. The new N stands for neural network. N stands for the neural network. The neural networks are constructed, implemented model of the human brain. The human brain is gradually developed, right? The human brain means the newborn baby. The human being, the only 2,000 neurons are there. So gradually what happened, the human brain gradually developed to become adult. 68 millions of neurons will be activated. And you remember one thing, the human being during the active time, less brain activation. During sleeping time, what happened, more brain will be activated that time. Performs a various type of tasks such as a pattern matching, classification, optimization function, approximation, vector quantization, or data clustering, or data mining, whatever the works it perform on the basis of artificial neural network. So these are the tasks is very, very difficult to traditional computers. Now, ANN come to propose. So basically, ANN is nothing but the large number of processing elements. So here, large means we can put N is equal to N numbers. We can put, imagine N is equal to anything, whatever, but processing capability will be take more time. And this processing element, we call the nodes or neurons. Right? We can generally call the neurons. And each neuron is nothing but one entity will be take input. Each neuron will take the one input and it will be work as a parallelly. Parallel means suppose your data points are there x1 to x100. That means I have to create a neural network 100 into 1. 100 to 1 means this is my neural network up to 100. Suppose this is 1 to 100, then everything coming to 1. So this is called the architecture of 100 cross 1, right? Suppose someone taking 100 cross 2 cross 1. So how to build? Suppose this is 100 data points are there. Here 2, here 1. So these are called the 100 data points. We connect each other, right? Then finally these two. And this architecture is nothing but 100 cross 2 and cross 1. Now we can put a question, so why 2 is here? So this 2 is nothing but hidden layer. This 2 is nothing but, I'll tell you details. The hidden layer. What is the role of the hidden layer? All that also I'll tell you, no problem. So this architecture, what happened by human brain will be mapping with your artificial neural network. And each link associated with weights, and which contain information about the input signal. And what weight represent? Weight is nothing but weights carry. Suppose a signal. Suppose your signal sinusoidal signal is there. The signal carries some information, right? Or this signal is nothing but some weight, and weight carry associated with the information. Then how the weight is associated? Suppose x1 is equal to 2 and weight is equal to 0.1. So W1, so we can call the M is equal to x1 into W1. So we multiply this, right? You have to multiply this. Similarly, x2 into W2, multiply this. So that's why it should be carry the information. And each neuron has an internal state on which is the function of the input neuron, that is the activation level. That means after getting information, so there is activation function is there. Suppose this is activation function, this is represent activation function. The activation function, what happened? All the information they receive. And this information means M. And what is M? I already told you. This is M. Multiple of each weight vector with input divided by N and this M. And this input vector, or you can call the activation function, will give the output. Suppose output is equal to 0 or 1, and this output may be 0 or 1, may be any number between 0 and 1. That is the depend upon what type of activation function are using, and the output of this activation function passes the information to another neuron, Like that, such number of neurons are there in our human brain. That is nothing but the 86 million number of human brain. And finally, you get the result. And in this way, artificial neural network also develop. If a human being thinking, why not a computer can do? So the way human being thinking, the same algorithm on same flowchart, if you fit to the computer can do in terms of high processing capability. But human being does not have that much of high processing capability. For example, I'll tell you 2481 multiply by 3481, you cannot tell without help of pen and paper. If you write an algorithm for that, the computer will tell. The same thing algorithm given a neural network, the neural network can tell, because the processing capacity of computer will be very, very faster than the human brain. Now, artificial neural networks, the different types are there. So I will tell you only one type. So because n number types are there, I classify different types. One is called the feed-forward neural networks. One is called the convolutional neural network. One is called modular neural network. One is called recurrent neural network. So these two, recurrent and convolutional neural network, people are nowadays frequently using, huge amount of using application, various applications. Your robot surgery, CNN, right? Your image classification, CNN. Surveillance system by robots, CNN, right? Now T20, you see the robots are moving to identify some mess. That also CNN. Recurrent neural network, CNN is called the advanced version of artificial neural network. Advanced version of artificial neural network. And people are using nowadays everywhere. Artificial neural network in terms of recurrent neural network and the CNN. And the feed-forward neural network, people are using 1965 to 1990s. People are using this feed-forward neural network just to getting the information, forecasting of a particular items, or you can put a prediction particular item, or the recommender system engine, like that they're using. Now, so what is feed-forward? Feed means input, forward means transfer to others plus. That is forward. So I'll pass information, just pass the information to madam, today my class over. That means I am unable to contact madam. You are staying with madam, so you pass to madam. That is called forward. The message to be forward one layer to another layer. That is called the forward. Now look at here. I told you this circle is nothing but one neuron. Any doubt you can ask me. So you are gradually going toward the complex system. Each neuron represent is a one input. So what is the input here? Input nothing but your matrix, as I already told you. I want to identify how many participants are okay. Yes, madam.
Good evening, sir.
Yes.
Sir, I joined little late, like 10 minutes late,
Okay.
sir.
Okay.
So
Hmm.
little disconnected on the concept. So while I understand that we are trying to learn the neuron structure and different layers to it, so is it the different layers of the artificial intelligence, the network within the artificial intelligence and its input, or we are referring to our brain system, like, or we are trying to relate our internal brain system as well as the artificial intelligence network, how it is connected from the base in terms of the coding must be happening, and I wanted to have that concept, sir, please.
You are asking this slide only, right?
Yes, like
Okay.
overall concept of today's class, sir.
Okay, today class, what I'm going to explain, as of now, in machine learning, we have learned the KNN, clustering, K, you can call the K-mean, like that, okay? So today I'm going to explain more advanced version, how artificial neural network help for the decision making for your talent acquisition or talent your management, okay? And the HRM concept, okay? That I'm going to discuss by today by using ANN. So we already discussed the K-mean, KNN, we already discussed, right? So today I'm going to artificial neural network, the advanced version of we can get the ANN version. So that is my objective today.
Okay, so this
So,
is the internal network of the entire artificial intelligence, how it is working. Maybe things like ChatGPT or other than networks that you
they're using
mentioned, the
ChatGPT, they're
tools.
using CNN. ChatGPT also, they're
Okay.
using CNN algorithm, right?
Okay,
They're
that's the
using CNN.
what we are learning today, sir, is the internal network, how
How
these
ANN work,
uh,
how ANN work, and
hmm.
how ANN related to your biological network.
Okay, sir.
Your
Thank you.
biological brain, this is nothing but a connection of different type of nodes, or you can call a different type of synaptic junction, right? How they're connecting. So 86 billion of number of neurons are they connected. Massive, we can call the structure, right? So I'm just explaining how this brain signal will be work in terms of artificial neural network.
Okay.
So this input is nothing but, suppose I'm given one example, in this section or in this class, to identify on the basis of features, my output should be classified here male and female, right? So what input I'm given? Input I'm given age. Suppose age is nothing but the one input. Second input is nothing but your weight. So this is nothing but age. This is nothing but age. This is nothing but weight. This is not one hemoglobin level. This is nothing but height. This is nothing but the batch preference. Okay. So like the 60 students are there. So here input is nothing but age. First one is called the age. Are you getting or not? Age. Second input is nothing but weight. This is called the weight. Third input is nothing but hemoglobin level. Fourth input is nothing but what is fourth one? The age, weight, hemoglobin. Fourth one. This is the food preference.
Page non.
Okay. Veg, non-veg. Okay. This I'm given input. So my output will tells whether the particular person having male or female. That ANN will tells. So how will it work? The moment you pass the information of the particular information of input, so this input passes to the new level, new layer. This is called the layer, right? And this layer of what information is there? Suppose this is X1, X2, like that, X4. So what they receive? X1, W1. And this W1 is nothing but, I'm asking 0 to 1, random number, 0 to 1, any number 0 to 1, including 0 and 1. And this is nothing but received from the X2, W2, right? So what he received? So this received for the M1, or can the layer 1, better record the layer 1. Layer 1 received X1, W1, plot X2, W2, like that, X4, W4, yes or no? Similarly, he also received, he also received, he also received, he also received. And this node having the activation function, Suppose activation I call the 10 language e to the power minus 1 x by x. This is my activation functions. And after activation function, what happens? You pass the information to the second layer. Here also same activation function, second layer. Here also same. Like this also receiving what? This also receiving x1 w1 plus x1 prime w1. Similarly, x2 prime w2 like that. So similarly, what you're receiving? So same process like previously. So what we'll do here? This process will getting output. The output will go to again back. That is called the back propagation. Now, why you asking the back? Because you given the threshold point. The threshold point is nothing but 0.5. Once you train the network, once you not getting 0.5, you pass the information to again to become train the data point again, unless until you are not reach your exactly goal. I've given one beautiful example. In your home, definitely kids might be learn the table. Yes or no? Table in your kids, they must be learn table. Yes or no? Tell me. 5 into 1 is equal to 5. Like that, 5 into 10 is equal to 50. If you ask your kids, can you tell me 5 into 8 how much? So what will do initially? You ask them, please tell 5 into the 5, 5 to the 20, 5 to 10, like that, 5 10 to 50, tells 20 times. Tell 20 times. This is called the learning. This is called the learning. The moment you ask 5 into 8 how much, if he or she will tell 35, your exact value is equal to 40, but she tells 35, that means your error is 5. You are not satisfied. So what will do? You tell no, go again, you have to read. This is not back propagation. This is not back propagation. Your threshold point is 40. Since you are not reached 40, so what you given instruction to your kids? Please go again read 10 times. So your kids will read 20, 30, 40, 100 times, unless until you will tell 5, 8 is a 40. Are you getting or not? Similarly, in neural network, what happen? You reach a threshold point. If you reach your threshold point, then what happen? You stop the training. You stop the training and give the output. This is called the difference actual value. And this output, an expected output, this actual output, an expected output, this is called the x minus x hat. This is nothing but your error. And this error is accepted by being a researcher. You have to accept. Error never be zero. I told you every times. Error never be zero. Error should be negligible. Today I'm going to explain in your R programming how error will be giving some value 0.12, 0.13 like that. Up to this clear or not? Tell me. Up to this clear? Back propagation, how will it work? Clear? Should I move forward?
So what I understood, I think we are constantly with the various inputs, Professor Mohanty, we are constantly training the neurons, the networks, correct? To able to give the output that we desire. And there are mathematical formulations until and unless that output is close to reality that we have
exact value.
Doing the back propagation every time. And there are mathematical formulas that.
So every time what happens, you run the program, you see the sometimes what happens, it will be saturation will come. After saturation means beyond that, suppose the error is 0.2. If you run 100 times, error also 0.2. Previously error was 0.4, now error is 0.2. And won't do running like that. So error is never reduced 0.2. That means you stop the criteria there. That means the neural network already saturated. No more will be work. Okay, so that is called saturation level. Now we see the same thing as I explained. So these things we can explain more. X1 is called the input. This is the neuron. This is the X2. And this is Y is called my output. And W1. So like that, you can multiply. And this is nothing but the Y. And this function is nothing but a function that you define. that is called the Y in. That means Y will be input, and finally Y in is equal to W1 X1, W2 X2. For these two variables, if it is X3, then WX3 and W3, like that. So this Y receive this input. This Y receive this input. So like that, we can call the WN XN. After this Y, use the activation functions, and produce the output. So this is called a general neural network. Very, very fundamental things, this one. And this is not like that in general happen. This is very, very complex structure. High dimensional complex structure, the neural network will be 1. So input is equal to X, multiply your M, the linear way, you will M, so M is nothing but M into X. So this is nothing but your linear equation, right? Now, in human nervous system, how it will work? As I already told you by showing the Indian map, like that some monkey and koala. So you can receptors, nothing but the sensor organ through which you can receive. Then passes the information to a central nerve systems. And central nerve system, what happened? The effectors. And effector also passing the feedback to central nervous system, then passing the information. Then what happened? The external feedback is going. So this is the continuous process. This is a continuous process. You know how much one processing time? 10 to the power minus 9. One signal millisecond. One signal processing time is equal to human brain. I'm telling adult human brain. That means the healthy adult human brain, one signal going to processing 10 to the power minus 9 nanosecond. So that much of a signal will be going on, right? Now coming to biological neural network, as I already told you, the 3 parts, the soma, dendrite, and axons, I already. And synapses junction is 2 types, one inhibitory and excitatory. So this is not required for the knowledge point of view, just remember. So the receiving the call and the forwarding the calls in the basis of impulses are working in your human brains. Now, this is very, very important. So you can remember here how we will compare the human, those are joined late for them, biological human neural network, then artificial neural network. In biological neural network, what happened? The neural network, neurons or human brain are process the informations naturally. Similarly, in your artificial neural network, computational model will be fixed by using the user. They find a n-dimensional computational model, and we can find out the human brain how to be work on the basis of machine learning and AI. Basic units are input are called the neurons, or you can call the cell. Here, what happen? We call the node or perceptron. Here, structure is nothing but a billion number neurons are connected to the synapses, and in between 2 synapses, there is a chemical substance are there. That is nothing but the sodium, potassium, calcium, like that. Here, what happened? The input layer, hidden layer, and the output layer. Learning process is nothing but the experience, practice, and biological adaptation. Here, what happened? Such as back propagation and the training data on the learning. And processing speed is nothing but the slower signal transmission, but highly parallel efficient. But here what happened? Very fast numerical computation using computers like the GPU, like that. Okay. Energy consumption is very energy efficient. Human brain use about 20 watts. So here what happened? More power depending the hardware and the model size. That depends upon what type of system we are implementing. And fault tolerance means highly robust, can still function even some neurons fails. I'll give you one example here. The less tolerant failure nodes incorrect training may be affect performance. Here what happened? The tolerant capacity is very, very less. That means human tolerance, the system tolerance very, very less, right? We can go for any type of failure of the nodes, then only tolerance capacity is there. So what is the exact mean tolerance means? The human being, right? So let me give one example. Suppose today I'm coming to lecture about my body temperature is equal to 98.5. Tomorrow also I'm taking one more lecture, my body temperature is equal to 99.5. Day after tomorrow also I'm taking lecture, my body temperature is 100.5. But day after also my body temperature is 101, but I am unable to take any class. That means my tolerance capacity up to 100.5 Fahrenheit. After that, my body temperature is, I am unable to take class because my tolerance capacity up to 100. Similarly, in artificial neural network, what is the tolerance capacity? How much error you can tolerate. Suppose you give the input, you got the output. Up to how much error you can tolerate. Suppose someone saying, I can tolerate error is equal to 0.1, that means 1%. Someone saying I can tolerate 0.2 means 2%, like that. Okay. For example, I'll tell you, can you tell me the solution 1550 multiply by 1520? What should the answer? What should the answer? Randomly, anybody can tell me. Randomly, anybody can tell me. What's the answer? What's the answer? Randomly tell anybody can randomly tell me. 1550, 1520. What's the randomly can anybody can tell me. Quickly tell me anyone.
225, something odd.
So someone maybe tells it may be starting from 2, 3 followed by 6, 0. Someone saying 2, 3, 4, 5 followed by 4, 0. Right, randomly I'm telling you, okay. Someone telling 2, 4, 2, 3 followed by 2, 0, right? So here what happened, these all are acceptable in neural network. In neural network, nothing is wrong, nothing is correct. All are acceptable, right? Suppose actual value is equal to, I have calculated actual value is equal to 1520, 1550 is equal to 2356000, whose value are exactly close to this value, that will be acceptable. Are you getting or not? All are correct. All are correct, right? As per your nervous system, you give the output. All are correct. Someone saying the difference is equal to 4000. That means more error is there. The difference is equal to 3000. Less error is there. Someone saying suddenly, suppose very capable, the difference is equal to 15. Only 15. That means this is almost 99% correct. Are you getting or not? 99% correct. That means suppose X person telling only difference 15, this value, that means this value is perfectly matched with this value. That means 99. So output of the neural network, you can appreciate this will be a very good model they have applied. So in output of ANN, nothing is wrong, nothing is correct, wrong or correct. All are acceptable, but thing is that which one is more acceptable on the basis of your error level is concerned. Now coming to gradually some mathematical part, right? So McCulloch and Pete's neurons, they develop one mathematically tools and identify the one called the activation function. Same thing, x1 is nothing but the input, w is weight. They given the activation function t. The t is nothing but zeroth layer, output at a k plus 1 layer is nothing but 1. When it will be 1? If the summation 1 is equal to n, why summation 1 to n? Because n number of inputs. So wi xi of n is greater than equal to t, then it will be 1. If less than equal to t, then it will be 0. So they develop this method. Okay. So I will be discuss the artificial neural net not much, okay, because my target is I'm coming to the data set and I'm coming to ANN, right? So I will be discuss another 5 to 10 minutes and that jump to what I'm going to your R programming, so that you be easily you can enjoy the lecture, okay? Because these all mathematics, okay? This is the you can call the backbone of the artificial neural net, how artificial neural net work, okay? So this is the way you can find out. Then this is called the logical gate, you can the JOR gate, NOR gate, or can the different type of gates are there, NAND gate, AND gate. So this is nothing but AND gate, right? And here what happened, you see the back propagation again passing to input to this value. So again go on passing unless until this OK plus 1 output of the K plus 1 layer is not equal to SK, the memory cell. So in this way, we can make plus fit neural network will be 1. So they develop neural network, we can using these artificial functions. Similarly, the features are there, not need to discuss. Now, another feature functions are there, the connection process symptom unit. So you can see the synaptic junction. So this is not the synaptic junction, the biological neural network, and the function is there. Multiple weights are there, weight function. So this is nothing but x1 up to x2 is nothing but the multiply by weight, w1, w2, and this is nothing but y1. This is nothing but y1 to yn. So this is the matrix formulate. So this is the matrix we can formulate on the basis of McCluskey fit neural network. Now, activation they use a sigmoidal function. So I already told you, sigmoidal function is nothing but 1 by 1 plus e to the power minus x, and this x is nothing but the neuron. So each neuron they find the activation function, and this activation function will give the output, and this output passes to the another neuron. So these are the activation function. I already told you the bipolar. So bipolar means what happened? The two neurons receiving the one neuron receiving the signal from the both sides. That's a bipolar. And unipolar means one neuron receiving the signal from the one side, right? So that's called the we can call the unipolar. Now, suppose I'm given one signal. Suppose you test the soup, right? You can recipe prepare a soup, and that soup will test. So I will ask you, the soup, how what is it, too much hot or too much spicy or sweet? So you tell sir spicy. Then again I was asking question, is it hot or not hot? So answer is hot. That means hot is nothing but receiving one signal, and spicy is another signal. That means your neuron, this is called the bipolar. So receiving one signal is hot or not, and receiving another signal for the spicy or not, right? So this type of signal is called the bipolar. Similarly, multipolar also there, receiving different type of signal but different direction. So this is not required. The threshold point I already told you this one for the binary perception. I'll go okay. The brain and artificial neural network, as I already told you, the microsecond, so 10 to the power 11 neurons are interconnection size and depends on the designer. So these are the fundamental things you just remember, and tolerance capacity and the control mechanism. Now I'm coming to that your output, the program. Okay, so basic model of ANN, we can find the one is interconnection, one is the learning rules, and the activation function. So I'm explaining here what is the learning rules. Non-linear rules means the set of rules you have to follow from the neural network. A neural network means, suppose this is a neural network, you have to learn a particular, as I given the topic example, your kids when you learn the particular table, right? Suppose this is nothing but the go on learning, and the activation function is nothing but the memory will be activated and passes the input to the another neuron. So these are the interconnection neuron. When you feed forward means the passes the information to another. Feedback means passes the information to another neuron. A recurrent means the passes the information to himself only. Okay, then called the single layer, a multi-layer, and the single layer, multi-layer. I'm coming to the code programming. Okay, I'm just skipping because this PPT I'm already given to you. Okay. So these are the supervised learning, unsupervised learning. If you permit another class, I will tell details. I'm coming to see. This is the presentation I already told. Right? This already I told. I'm coming to your output. Some example I'm given. Okay, this is the example. Okay, suppose in 10-line acquisition, what happened? What are the major role of the artificial neural network? That means application of artificial neural network in your talent management, right? The first one is nothing but the talent acquisition and recruitment, and second one, employee performance prediction. Third one, employee attrition prediction. Similarly, the fourth, training development needs, succession planning, employee engagement analysis, workforce planning, salary compensation optimization. These are the various areas you can apply the ANN. But today, I will explain only three things. One is called the talent acquisition recruitment. One is employee performance prediction and employee attrition prediction. So these three I'm explaining because I prepare for these three because I know time constant is there. If a time permit, I'll take one more class and all this other will be, I can explain, no problem. Okay. So in talent acquisition and recruitment, what exactly happened? You have to predict best candidate, right? So now you tell me the word, what does mean best? What does mean best? What does mean best? Anybody quickly tell me. What does mean best? Best candidate means? What is the best candidate?
Closest fit to the job description, to the list, to the
It is the best
prescribed.
candidate. It is the best candidate, right?
Yeah. And someone
Okay.
closest fit to the others can, I mean, there are recruitment specialists here, please.
Okay. So I can say the suitable candidate.
Skills aligned mostly to the job description who fits the bill.
Okay. So I can say it is a suitable candidate for that particular post, right? So on the basis of different scenario, you have to find the best candidate, right? Without human error, how to, suppose you want job ID you created, for that job ID, you get the 1,000 number of resumes are there. So out of 1,000 number of resumes, suppose some resume maybe some influencer coming, maybe your family, maybe your wife, or maybe your husband, maybe the influence, no, this is the best candidate you can. So human bias might be there, right? So why not we apply the ANN technique who can reduce the bias? So there's no bias, human ANN can be taken. So that's why what we'll do for the process is that the process is nothing but the resume analysis, the resume have to analysis, okay? Then the experience definitely will count. Skill set must be there. Again, skill also two types, technical skill and soft skill. Then what happened? The rank will be predicted. So after rank will predict, whoever the highest rank, automatically they'll be suitable candidate for that particular post, right? Then to reduce the bias, improve the selection accuracy, I have to adapt the ANN application, right? I'm coming to first one, okay? I'm coming to first one. I'm coming to first one. So this is, yes, talent management. Now screen visible? Is screen visible?
Yes, sir.
Okay, so I'm going to explain. So I installed the packages. There is a neural network package is there, okay? Package is there. So no need to write. So the way I'm explaining input X1, W1, then given the Y and Y given to back propagation like that. So everything is defined in a neural network. So what you'll do, you have to apply the data, then you run the program, then you will get the output, then you will interpret the output. That is your objective, right? I explained here, install the packages, neural networks. Then after install the packages, the library you have to install. As you know, these are rules you have to follow. Then what happened? In data set, I considered as per my knowledge, the data set is nothing but the experience. So experience nothing but the years. Here, how many persons? I'm given the simplicity for the 10 person. Person number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, you can consider 1,000, 1 million, 10 million, anything you can consider, absolutely no problem. Right? So for the first one having 2 years experience, second one is 5, last one having 5. Skill score. This skill score is nothing but technical skill score. So how you define skill score? I already discussed my previous class. Okay. Skill score is equal to 60, 85, 90, like that. The skill score of the person 10 is equal to 80. Education 1 for the BTech, 2 for the master, 3 for the PhD or higher degree. Like that I define. Certification means how many course certified he did. 1 means 1 certification in the year. 3 means 3 certification in the year. 4 means 4 certification like that. Just that. And this is my output variables. So if the output is equal to 1, that means it's selected. If output is equal to 0, that means it's not selected. This is my assumption. Okay, I did. Accordingly, I write a program. 1 is equal to select and 0 is equal to not select. According to I fix the what threshold point. Okay. Everybody clear in this data point? Should I proceed? Should I proceed? Should I proceed?
Yes, sir.
Yeah. Now what will do? I normalize the data. Now the question, why normalize data? Why put 2 here? 2 means I normalize the data in column wise. 2 stands for column, 1 stands for row. Row is nothing but your instances, means individual information. Suppose 1 information having experience, skill score, education, certification, selection. 1 individual. Similar 2 individual like that. So I don't want to for the row, because row I don't want, because I need the data should be trained. Row will be the no data. Row is called the participant or the employee, right? Or the potential employee you want to hire. I want to data should be a train, that's called the column attributes, right? 2 stands for column. So what I did, I become normalized. Normalized means I identify. Suppose I can tell you 1 to 100 data points are there. I want to normalize from 0 to 1. How to do it? Anybody can tell quickly. 0 to 100 data set I have. I want to normalize from 0 to 1. How to do it? How to do it? How to do it? Tell me. Are you getting my question on? Are you getting my question on? Not getting? You're not getting the answer, then how will I know? Suppose 1 to 100 data points are there. I want to see all the data from 0 to 1. So what will do? I divide by 100 to each one, maximum value. I divide by 100 maximum value. So 1 to 100 maximum value is 100. So 1 by 100 is equal to 0.01. So 100 by 100 is equal to 1. So all the data points that is starting from 0.01 to 1, right? In this way, I can minimize, right? So we can call the normalize. So in this way, I did the normalize here. Then what happened? I find out the data points should be learned. Then after that, what happened? The 80% data I have to train. 80% data I have to train. That's why I want to column 8. Why make up 8? Because column number 8, right? Column number 8. Then the column number 9, particularly column number 9, 10 becomes what? I can test, right? I test the data. Then, so what happened? So I model, you can use the model, and this model is nothing but I have to take the selection my output variable. So till operator, who will be present before till operator, that is output variable, and I take the input variable, nothing but experience, skill score, education, certification. So experience plus skill score plus education plus certification, right? These are my 4 input, and this is my what we can call the output. Hidden layer, I consider the 3 on the basis of we can call the training, right? In this way, I can find out. In this way, I can identify out. Then I can plot the model. Now see the beautiful model you would see. This model is nothing but, see, random numbers are there. I told you now, -1 to 0, -1 to 1. Random model, the weights they have generated. These are the random model generated. Why this blue color? This blue color is nothing but after getting the input from this experience, the skill score, education, certification passes to this second layer. So it's the third layer like that. So hidden layer is equal to 2. So here 1 is given nothing but the bias. Bias is nothing but tuning parameter of the particular neural network. So that is called bias. So in this way, my output is equal to this one. Now you see error is equal to.
Professor, what is the bias? I mean,
bias is
technical
bias.
definition. So what can be
tell
the
me.
example of a bias here?
Okay, bias means a tuning parameter. Bias means a tuning parameter who can tune the network. For example, suppose suppose you don't have any television. Okay, you want to cricket match is going on. Okay, you have to listening the cricket news by radio, right? Sometimes what happen that signal you are tuning the parameter, yes or no? So which signal will be more the audio signal is clearly audible to you, you are tuning the parameters, and that tuning parameter is nothing but bias here. So in this case what happened, I using the bias is equal to 1. So in this case bias is equal to 1. So that bias we can multiply, we can give the result, right? So in this way, selection is equal to 0. So I make it here 0.46. So if selection criteria is less than 0.5, not selected, is greater than 0.5, is selected, right? In this way, I can compute. Then finally, when you find the model test features, so these are the test feature is 1 to 4, to compute the model. Now you see, I feature the predicted value. If the particular output is 0.5 is greater than 0.5, answer is equal to 1. If less than 0.5, other than greater than 0.5 is equal to 0. So this predicted value I given. Then I got the output. If result you can see, the result you can see here. Now you can see what the result, why is coming this one. Result you see, what the result is coming. Is visible result. Now see 1 and 9. That means 9th and 10th candidate is selected for the what? The job, right? So similarly, I'm coming to performance. The performance is nothing but the employee performance in the prediction. So here what I'll do, I pass the same thing. No need to explain this thing. So I got it here: experience, skill score, education, training hours, and performance. So these all the data are there. I compute here. Then so I delete this one previous diagram so that you can get the new diagram. Then this is nothing but the we can call the normalization. After normalization, so what we'll do, use employee identify. Then next, I may split data set into 80 and 910. You can put, see here I'm doing 80% data training, 20% data testing. Okay. In next class, I'll tell you training, testing, validation also. Okay. The validate. Here, why put 80%? It's not like that. We can put also, we can call the 70% also can put 7%. Here you can 8, 9, 10, 30% also do. No problem. Okay. So that depends upon you. But there is no thumb rule says there, but you have to learn more data should be trained and less data should be tested. If training error is more, testing error is less, that means it's a overfitting. Okay.
So, Professor,
So try to, yeah.
These AI hiring tools, like for example, yesterday we had seen a demo of one of our partner, one of the,
Yeah.
they would ideally, I mean, their developers who are designing those would perhaps use these models, is what you're
Yeah. They're
That's-
using a CNN model. CNN model.
What is
They're
this?
using CNN models. Convolutional neural model. I told you this is the very fundamental things of artificial
Okay.
model. Convolutional model, higher version of the artificial neural model, right? Now see, here error is equal to 0.00. Look at it. Is it visible? My last line you can see here. I movement the cursor, right? Is visible or not?
Yes, yes.
0.0. Now step 164, what is the meaning? 164 time it will train. 164 time will be trained. So the performance you can measure here. Now the predicted value, the result is there. Now see the 8, 9, 10. This I told you, na 8, 9, 10. The 30% the testing, right? 8, 9, 10. So that's why 8, 9, 10 is coming. Then the resultant prediction, you see the performance. 8 having 67%, 9 having 95%, 10 having 50%. So what is the meaning of this one? The meaning says that, so when you compute a particular employee performance, the performance level is the first person having 67, second person having 95, and third person having 50. You go to the interpretation. I also put an interpretation here. This is the first one. The performance is the second one. What interpretation? First one is 95 for the 45. So I make it the 80 and the 20. So is there the employee number 9 predict the performance score 95.43. That means which indicate very high performance. The HR manager maybe suggest that employee having strong attribute, having experience, skill, education, training. So ANN model predict excellent performance. You can give the award. You get given the award. But the second employee, 45% skill score. Okay, madam, you can ask.
But I have a question that while you showed everything related to the R programming, right? We entered the code and then this beautiful diagram also came in terms of experience, skills, code education, and training hours. So, is there any other way also, sir? Like, example, like I am not the expert in the coding and maybe very limited exposure I will have in future also in terms of the coding, but there are other tools also that I can use. So I wanted to check from that angle, because if we are able to continuously, all of us in our respective companies, if we are able to do this part, then it will be useful in our respective roles. So I wanted to check, is it possible through Chat GPT or something else? Sir?
See, this is the common question I'm receiving for every my class. Okay. I told you repeatedly many times what I'm going to explain through R programming, because I'm the expertise in R programming. Are you getting or not? I'm going to explain how CNN work. I'm going to explain how KNN work. I'm going to explain how KMN work, right? I'm not telling you read the R programming. No need to read R programming. You can use ChatGPT, no problem. You can use the Perplexity. You can use the Copilot. You can use anything you can use, right? But how it will be used, that you have to see. What insight behind it, that you have to know. So domain knowledge, you have to know how artificial neural network work. Suppose in the future you want to develop a particular product, if you don't know ANN, you cannot implement. So that's why the basic things I'm telling today, how ANN work. Initially I told ANN how it will work. I think you are missing the first class. I told you, right? The human brain, I'm giving some animal figure, I'm giving an Indian figure.
I was there. I was there, sir. I was
So
there.
that's what I'm telling. So how you remember these things? So this
Mm.
biological neuron, then I convert to artificial neural network, all the functionality of biological neural network, how to convert to artificial neural network. Then I writing the particular program related to your talent acquisition, right? So in this way, how to interpret, that is more important. Suppose you apply the ChatGPT, no problem. ChatGPT using artificial neural network, ChatGPT give the output. Okay, no problem. You no need to know also artificial neural network, right? How ChatGPT works, that you don't know, right? Suppose you are going to restaurant, you recipe, you order, you test it, then if it is good, you can excellent. But you never ask to who is the chef, what type of ingredients are putting in this biryani masala like that. You never ask, right? No need to also ask, right? So that means you have to interpret. If the taste is good, then definitely this type of ingredient must be there. Similarly, here, if employee 9 having 95% 4.3 performance score, what is your next? What you will do with 95.3? That means you can tell by using this score, because you don't have time to all consider all the input of the particular parameter of the particular employee. So that output will give 95.43. So that output you can interpret by yourself. Similarly, the employee number 10, 45.406. So what is the lower performance? So that means you can tell them you are eligible for the more tenure in the future. So that you can do it, no problem.
Sir, thank you. Sir, one more thing, that would this diagram also be possible through like any other tools, sir?
Yes.
If you try to explore.
Yes, Python also can do. Python also can do.
Because this gives a lot of like sense, like it gives us the deep knowledge that how the outcome has come.
Yes.
While we have inputted all the coding in the R programming, sir, but it is giving a logic that what exactly made this color as blue. So
Yeah. Color is blue means, so I have to identify this black color is nothing but the input weight of the first layer. Blue color is nothing but the input weight of the second layer or third layer, like that. Okay. So that's what distinguish. Otherwise, all are black, it's no problem. Okay. Then, so this is the neural network model prediction. My last example, I tell you what is the problems. So last example is nothing but your that is called the attrition rate. Okay, attrition rate is nothing but your I'm using input is nothing but the experience, salary, job satisfaction, work. See, every input, every problem having different input, right? So this salary is not there in the two previous by performance and the talent management, right? So this is called the another way we can identify. I run the total program at a time. Same thing. So I can close this one. You can identify easily, remove the figure. So a new figure will come. So this I can directly run. So here I can directly run. Same thing. I've used here 80% and 20%. Now see run the programs. Now see here. Job satisfaction also there, the experience, salary, job satisfaction, and the working hour. So output is equal to 9 is equal to 0, 10 is equal to 1. So what the meaning? 9 is equal to 0, 10 is equal to 1. So this is nothing but 0. I told you the 0 transfer 1 transfer 0, 1 transfer what? Employee likely to be leave. 1 means employee likely to be leave. I mentioned the 1 indicate employee likely to be leave, and 0 employee, 0 transfer employee to be stay. So what my output? Output says 9 is equal to 0 and 10 is equal to 1. What basis? 0, 1. Because 9 having give a value is equal to 0.01 and 10 having value is equal to 0.99. That means 99%. This is the value. Then again I have to class. I may convert into class. Okay. To convert into class prediction. This value I'm getting, I convert it to class prediction. The class prediction means I define if value is equal to 0.5, if value is equal to 1, and less than other than 0.5, value is equal to 0. Since it is a 0.99 is greater than 0.5, it will be 1. Okay. In this way, that means the employee 10 are likely to be likely to be leave, and employee 9 will be likely to be stay. Now coming to interpretation, the same thing. So what I present here, I'm presenting there here also presenting. Now he's saying that you see 99. So same thing can find employee 10 has a predicted probability 0.99, which closest to 1 suggests that he likely to be leave. Highly probability is there to likely to leave the organizations. So in this way, today what I discussed the very fundamental things of artificial neural network. Then I compare biological neural network to artificial neural network. Then I find out the some different type of neural network or the classification training. Okay, then we'll convert to this type of example how talent acquisition is there. The major problem in talent acquisition. So I've given the time permit. I've given the three different data set with the help of three problem. One is called talent acquisition recruitment. One is called talent employee performance prediction, and the employee attention prediction. Okay. Any doubt you can ask me. I think time over. You can ask any question you can ask me.
So just one question, like we checked on employee attrition prediction,
Okay.
and the parameters that we considered was promotion, salary revision, or training. So with this R programming or any other tools, sir, is there a way that we get some suggestion also? What can be the way forward apart from the HR basic things that usually happens in
What
any
is your
other?
query? What is your query? Can you tell me? You need more parameter, right? Or what?
Maybe parameters or maybe a suggestion that what can be the best thing. Like every organization has a limit to how many
No problem.
promotions somebody can have.
I am see.
So.
I got your point. For simplicity, I'm given the 6 parameter, right? For simplicity, I'm given the for experience. We can call the this is nothing but your employee per person. So this is nothing but third one, na?
Yes, the last
Third,
example.
last
Employee
example, right?
relation.
So employee core. So I'm given here 5-6 parameter for simplicity, right? You can fuse 1,000 parameter, 1,000 parameter, 10,000 parameter. Absolutely, there is no problem. But you have to think which parameter is really take the decision for the employee retention. For example, male and female. Male and female, I'm thinking for employee retention is there. Other condition, are your AC is working or not? Are you thinking these are the parameters for employee retention? So that you have to think which parameter is related to. So for launch hour in your company, they declare 1 o'clock. Some company launch hour having 1:30. Okay. Are you thinking launch hour is one of the parameter for employee attention? Are you thinking?
Launch hour, the start of the shift, sir?
No, I'm telling suppose your company having launch hour, suppose 1 to 2. Suppose the banking system,
Or
whatever
lunch.
launch hour is 1 to 2. Okay.
Okay.
So is it the launch hour is the attention mechanism? Is attribute for attention? Is it required? Is it the parameter? My question is it the parameter?
No, that may or may not, because usually these days we hear that there are a lot of meetings, If maybe they are not getting time to have lunch, that can be one of the parameter. And maybe as a suggestion, what we can do as HR professions, that if we belong to a certain designation, maybe some kind of
Yes,
input
that
we
I'm saying.
can
So
give
you have
that
to
some
being a
dedicated hours.
analytics, you have to think what are the real parameters are involved this one. Okay. So these real parameters for the attention. That if so I'm giving consider here experience, salary, job satisfaction, working hour. So being I'm not HR guy. So I know what my knowledge perceive, salary, job satisfaction, work hours, these are the three major concern for the attention. You can put anything. Suppose you can put here launch hour. You can put here launch hour. LUNCH launch hour. So launch hour you can put here 1 hour, 30 minutes, 20 minutes, 1 hour. You can put it, no problem. So this is no problem. You can put another things. But here you have to add one things. Work hours plus launch hours. So that you can put. So male and female. Male and female, male is equal to 1, female is equal to 0. Are you thinking male and female is responsible for the attention? Gender, are you thinking gender is really
Not.
applicable? Huh? No, they
Maybe
don't
not.
put. They don't put. Suppose weight of the employee. Are you thinking weight of the employee is prediction for the attention? No. Are you getting or not?
And sir, yeah. And sir, my question was also that based on this, would we get some kind of suggestion also as next steps? or just the input and then in regards to output the numbers, and then next steps will be our steps and not the
Next will
suggestions
be your
that will
step.
come
So
from here,
output
right?
you will getting. So ANN will give the output. Then that output you interpret and you can proceed as per your choice, as per your knowledge, as per your domain knowledge.
Okay, understood. Yeah, no other questions from my side. Thank you, sir.
Okay, any questions? Any questions? Someone chart. Someone? Any questions to all the participants? Sarvan Dada, any question?
No, sir, trying to grasp it, sir, to be honest.
Yeah.
Have to go through the recording once. Again, as I said, I mean, I'm trying to, so for
Yeah,
example, my summary for today is you have given score to every, I mean, you have given allotted, so those numbers, yeah.
Wait. Okay, thank you very much. I think no questions. Okay.
Thank you, sir.
Thank you,
Okay,
sir.
thank you.
Thanks, sir.
Thank you, sir.